Let's talk now about the effect of tides and what generates those. Those are a little bit different than waves, and their cause is a little bit different. So let's talk about that. Tides are caused by gravity effects. The two main ones that are going to affect us on Earth, because we're revolving around the sun and the moon in turn is revolving around us, that causes slight changes in gravity at Earth's surface, slight pulls on water in different spots. And the moon is what ends up controlling the major daily tides, high and low, twice a day. Then the sun itself is going to sort of have a secondary influence on those, and it regulates how high the high tides are and how low the low tides are, and creates what we call spring and neap tides. So spring tides are when there's a big gap between high and low tide, and neap tides are when there's a smaller gap. And the sun is what modulates those, both of them working through the force of gravity. There are other influences though. So tides can also be affected by the shoreline configuration and how the water will pile up along shorelines of different shapes, and also storms, because storms are associated with systems of low pressure, which tends to suck up just a little bit of water in a lens underneath that storm. So when big storms like hurricanes hit, they carry with them a storm surge that's somewhat related to tides, but certainly not caused by gravity in the same way. So overall, tides are caused by the moon's gravity. And there's a nice little animation here showing that, where this is the moon, right, and it's moving. And we're looking at the tide at this point. So that blue stick that's sitting there. When that point is directly under the moon or directly opposite the moon, you have a high tide. And when it is at 90 degrees, you have a low tide. So these are high, low, and low. And so that means that each day you have 2 high tides and 2 low tides, roughly. It's a little off because the moon is spinning at the same time the Earth is spinning. The way that it works is that gravity is going to pull water in Earth's contiguous oceans, because the ocean really spans Earth's surface, into these 2 piles or tidal bulges. It makes sense that there'd be one directly under the moon, because that's where the moon is closest and pulling the hardest on the water. But it also turns out that there's a pile on the other side of the moon as well. We won't worry too much about why that is. Turns out that the alignment of the sun also matters. So when the sun is aligned with the moon and then the Earth, when they're all in a line, you're going to have spring tides. So under those situations, the effect of the sun adds to the effect of the moon, and you get particularly high tides that are called spring tides. Also, you get particularly low tides. So both of those refer to spring tides. Big difference between high and low tides during those. Instead, when the sun is working opposite the effect of the moon, so when there's a 90-degree angle here between the position of the sun and the moon, you get neap tides. Here, the sun and the moon are working opposite one another, so the relative sizes of the high and low tides end up being pretty small. And these alternate roughly every 28 days, 2 spring and 2 neap every 28 days. That's the length of time it takes for the moon to revolve around Earth. So it makes sense that you would get 2 spring and 2 neap for each of those, just like you get 2 high and 2 low for each day. Tides are also affected by proximity to the shore. So here we have a map of just how high the highest tides are relative to the low tides. So your hotter colors, your reds, are places that you have very high tides, and your blues are places that you have very low tides. You can see that near the shore, tides tend to be larger. In some places, the coastline actually acts as a funnel too. So you have pretty high tides along, say, the coast of France, and here there are parts of Norway that do. And then the place that's famous for having the biggest high tides in the world are actually this tiny little corner of Canada. So the Bay of Fundy off Nova Scotia and New Brunswick in Canada, right? So here's just the very northeastern tip of Maine. And then here's where Canada starts, New Brunswick, Nova Scotia. And this sort of funnel shape of this Bay of Fundy ends up acting as a funnel. It happens to have a resonance period, much like we talked about earthquake, and buildings having particular resonance periods at which they tend to shake back and forth that naturally. Turns out that tides also can have a resonance period associated with them. And the resonance period of the Bay of Fundy, the rate at which water comes in and out naturally, equals the tide period, high and low twice a day. And as a result, you get incredibly high tides at the furthest reaches of the Bay of Fundy. So these, right, they go as high as 14 or 15 meters, 46 or 49 feet. That is nuts in relation to the sort of tides that we would see along the North Carolina coast of a few feet, 5, 6 feet at most, maybe. So these are huge tides that you can get. And that's because the coastline is magnifying the effect of gravity that is working on the tides themselves. In addition to tides, we can talk about storm surge effects. So I had mentioned that if you have a storm, this is a terrible image of a storm. I was trying to draw a hurricane. This is a big cloud now. Okay, let's not worry about it. It's associated with a low pressure system, which means that there's less force of the atmosphere pushing down under these storms. And as a result, you get this lens of high water that sort of forms underneath those storms. It can be several meters in height. So 5 meters, it's a little more than 15 feet. And when these coincide with high tides, or when you would have the largest storm surge, and you might call it a storm tide, because both of them are working on it at once. And as a result, you really have to be careful when those storms hit at the same time that a high tide happens, because it causes the most flooding possible on coastal regions. Let's talk a little bit more about storm surge. As I mentioned, that ocean water is going to bulge underneath storms. That's what storm surge is. And it's caused by storm winds pushing water onto the shore. So the winds are actually pushing that water onto the shore. It's also caused by the low pressure of the storm system, causing that ocean water to bulge in a lens underneath the storm. The storm surge itself starts to arrive before the storm arrives. So we'll get into this maybe a little bit when we're talking about hydrology too, but I will mention that these tropical cyclones, that's a classification for tropical storms, tropical depressions, and hurricanes, they're all called tropical cyclones. They all fall into that category. They are rotating systems of thunderstorms that originate in the tropics. The ones that hit our east coast and our Gulf Coast originate off the coast of Africa, but there are tropical cyclones that hit the Pacific Ocean as well. They're usually called typhoons instead, but it's the same system, and they are classified based on wind speed. Low winds and it's tropical depression, moderate strength winds and it's a tropical storm, high winds and it is a hurricane. And we can classify those hurricanes further based on their wind speed. Much like we have the moment magnitude scale for earthquakes or the volcanic explosivity index for volcanoes, we can describe the strength of hurricanes on the Saffir-Simpson scale. So when you hear about a category 1 or category 2 hurricane, those are categorized on this scale. And they're categorized by wind speed. And then it turns out that that wind speed is very highly correlated with the damage that they cause at landfall. So category 1 are going to cause some damage, up to category 5 are going to cause catastrophic damage because their wind speeds exceed 155 miles per hour. That's nuts. Of course, hurricanes can affect areas inland, but they particularly affect areas that are right on the coast due to that storm surge that I wanted to talk about. That storm surge is going to, because of the lower pressure under the storm, because of the winds of the storm forcing water onto shore, they're going to push the ocean water up abnormally high, sometimes by tens of feet at most, several meters. And they will inundate the area that's right along the shore with seawater. Not only is that really bad because now your whole house is full of water, but any sorts of electrical stuff that you have in there, because a lot of this is salty water, is going to corrode. And you can see some of the damage caused by some recent, fairly recent major hurricanes in these pictures here. Looking at this image, you can get a sense of just how far some of that storm surge has reached, because you see the reflection of the water that's collected from the storm surge miles and miles away. You can see that little pool of water right there. That's all because the storm surge has pushed this far into shore. And just now that the storm is cleared, is that water, as you can tell, flowing back offshore. It's actually a little bit like a tsunami when you look at it like this. It comes onto shore, and then a lot of the damage comes as things are being pulled back offshore too. Certainly wouldn't want to be in this water at this point in time because it's moving very fast offshore. Those storm surge effects can cause some of the most extensive damage from the hurricanes, which is why the coastal areas are so especially at risk. Dunes are an important protection against at least normal levels of storm surge. They can't protect against something like a Hurricane Katrina level hit everywhere. But these dunes, like you see oftentimes along passive coasts, are these piles of sand. They have been formed by wind. Unlike a lot of sediment that gets moved around by water on shorelines, the dunes themselves are actually formed by wind piling up there. And those dunes get stabilized by plants. And we say halo tolerant because these are specialized plants that tolerate the salt in salt water nearby pretty well. So they're halo tolerant, salt tolerant plants. And they can protect against some storm surge, which is also why people get so mad when you go climbing on the dunes. Because if you're climbing around on the dunes, running around, breaking them down, then the houses that are behind it, everybody just inland of that is going to be more threatened because that dune is being broken down.